Hello students, today we will start with the third chapter, that is water. Uh, the chemical name of water is dihydrogen oxide and its formula is H2O. This much idea you all have. Now from the previous two chapters you now have the concept of how to calculate the molecular mass. So if we calculate the molecular mass of water, it will turn to be 18 atomic mass unit, because atomic mass of hydrogen is 1 and atomic mass of oxygen is 16, right? So two atoms of hydrogens are there and one atom of oxygen is there, so its molecular mass is 18. Now the molecular structure of water is this. This shape is called the bent structure. Okay, so this is the bent structure, and this is how we show the molecular structure of water. Now how these bonds are formed, I'll discuss this in the next chapter. So for now just remember this, that water has a bent structure. Okay, now if we talk about the state of water or availability of water, then we can say that water can exist in both the free state and combined state. So what is this free state and combined state? See, when we get water as ice or normally as liquid or in gaseous state, they are the free states of water. But combined state means in some salts there is the water of crystallization, and that water of crystallization gives the shape to the crystal of the salt. So that is called the combined state. I will discuss this later. So just now you keep it in mind that water exists both in the free state and combined state. Now if we speak about the physical properties, then we can say that water exists in the three physical states, that is solid, liquid and gas. So states are states to which the molecule water exists is solid, that means ice, liquid, that means water, and gas, that is the water vapor. Okay, so generally water exists in the liquid state and we call it as normal water only. So at normal pressure and normal room temperature, water exists in the liquid state. Clear? Now if we change the temperature of water, then it will change its states. Like if we heat the liquid water, then what will happen? On reaching 100 degrees Celsius, it will start boiling, and on boiling it will rapidly convert into the vapor state, that is the gaseous state. So from liquid it will turn to gas, that is on increasing the temperature water will change its state from liquid to gaseous state. Okay, and during this formation, this gas formation, it is absorbing some energy. So that heat energy which is absorbed to change this state is called the latent heat of vaporization. And after formation of the gas, if those vapors are condensed, then some energy is released in the form of heat. So the heat energy which is released when the water vapor gets condensed to form liquid water, that heat is called the latent heat of condensation. Clear? So latent heat of vaporization is the heat required to change the water into gaseous state, that is into its vapor state at its boiling point without any change in the temperature. This is the latent heat of vaporization. And latent heat of condensation means heat released when water vapor condenses back to water. So in this case, that is the latent heat of vaporization, heat is required. Okay, and in case of the latent heat of condensation, heat is liberated. This is the opposite phenomena, and this latent heat of vaporization is equal to the latent heat of condensation. Okay, both these energy quantities are same. Clear? Now we will discuss the physical properties of water. Among the physical properties, first thing we need to know is the nature of water. That means how does pure water look, or what are the tastes, how does it smell. All those properties include in the nature. Okay, so about the pure water, if the water is pure, that means only H2O is there and no other chemicals are there. In that condition, water is clear, transparent, and what? It is tasteless, colorless, and odorless. It has no taste, colorless, and odorless. So what does this mean? See, when we speak about the pure water, that means no other chemicals, no other minerals are there. So in that case, it is clear, okay, it is transparent, it is tasteless. Now you will say that, sister, we get some special tastes of water when we move to different regions, right? It is true, but in that case the water is not pure. If we taste the mineral water, it will taste something different, right? Because there are some dissolved gases or dissolved minerals. So those minerals, those dissolved minerals and those dissolved gases, they add the taste to the water. So if we speak about the pure water, there is no mineral, there is no dissolved gas. So in that case, it is tasteless. Okay. Absolutely, it is colorless. When the water is pure, no other chemicals are there, it is colorless also. And odorless, it has no specific smell, so it is odorless also. Clear? So the nature of pure water is clear, transparent, tasteless, colorless, and odorless. Okay. Next thing is the boiling point. We all know that the boiling point of water is 100 degrees Celsius. That means pure water boils at 100 degrees Celsius under normal pressure. That is under 1 atmospheric pressure or 760 millimeter of mercury. At that pressure, water boils at 100 degrees Celsius. So we are emphasizing on this pressure quantity, that at normal pressure, that is at 1 atmospheric pressure or 760 millimeter, sorry, it is millimeter, 760 millimeter of Hg, in that pressure pure water boils at 100 degrees Celsius. So why are we emphasizing in this pressure condition? This is because the boiling point of water is highly affected by the pressure. Okay, the boiling point of a liquid is considered as the temperature when vapor pressure is equal to the atmospheric pressure. So whenever a liquid starts boiling, it is dependent on the temperature when the vapor pressure is equal to the atmospheric pressure. Okay, so if there is any change in the atmospheric pressure or the vapor pressure, the boiling point of that liquid will change. Clear? So same thing applies for the water also. That is why, okay, we can say that if the pressure is high, if the atmospheric pressure is high, then the boiling point of that liquid will increase, and if the pressure is low, then the boiling point will also decrease. Clear? Now if we move towards the higher altitudes, that is if we move towards the hills, then water boils at the temperature lower than 100 degrees Celsius. Why is this so? We know that at higher altitudes the atmospheric pressure is low. Okay, so if the atmospheric pressure decreases, then the boiling point of water will also decrease. That is why in the hills water boils at a temperature lower than 100 degrees Celsius. Keep it in mind. Okay, and that is why food is not cooked properly there. It needs some more temperature, some more amount of boiling to get the food cooked properly. Clear? So in the hilly zones or hilly areas, water boils at the temperature lower than 100 degrees Celsius because the atmospheric pressure is low in the higher altitudes. Keep it in mind. Clear? Next physical property is the freezing point of water, or we can say the melting point of ice. Both are the same. We know that water is liquid at room temperature. So if we keep on decreasing the temperature, then on reaching 0 degrees Celsius, this water will start freezing. It will freeze at 0 degrees Celsius. Now if we take out the ice, okay, which has already been freezed, if we take that frozen water, that means the ice, it will start melting also at 0 degrees Celsius under normal pressure, that is 1 atmospheric pressure. So both the freezing point of water and melting point of ice is 0 degree Celsius under normal pressure. Clear? So the freezing point of water decreases with increase in pressure. If we increase the pressure, then freezing point will decrease. If we decrease the pressure, then freezing point will be 0 degree or sometimes more than that. Clear? So the freezing point of water also decreases due to the presence of dissolved impurities. So if there is any impurities, dissolved impurities in the water, then the boiling point of water will increase and the freezing point of water will decrease. So due to the presence of impurities, there is the change in boiling point and freezing point of water. Here, next physical property is the density of water, and it is very important. The density of water is maximum at 4 degrees Celsius. So from liquid, if we start decreasing the temperature, so before freezing at 4 degrees Celsius, the density of water is maximum and volume of water is minimum. At 4 degrees Celsius, water has its minimum volume. Okay. So if we further decrease after 4 degree, if we further decrease the temperature up to 0 degrees Celsius, in that condition water starts freezing. Okay. Now this is the reason that ice floats on water. Okay. We know that density is equal to mass by volume. Right. So if volume decreases, density will increase, and if volume increases, density will decrease. So at 4 degrees Celsius, it means water has the maximum density, that means it has the minimum volume. Clear? This is the reason why the ice floats on water, because ice is at 0 degrees Celsius, which is beyond 4 degrees Celsius. So in that case, its volume is maximum. Okay, it has the greater volume. After 4 degrees Celsius, if we further decrease the temperature, then its volume will start expanding. Okay, this is the anomalous nature of water, that below 4 degrees Celsius, water starts expanding, and we know that on freezing, the volume of ice increases. So on increasing the volume, the density will decrease. As the density decreases, so ice floats on water. This is the reason that ice floats on water. So if the question is that give reasons why ice floats on water, you need to mention that at 4 degrees Celsius, water has the maximum density and minimum volume, but on further decreasing the temperature, that is on reaching 0 degrees Celsius, water starts freezing. Okay, and on freezing, water starts expanding, the volume starts increasing. Okay, this minimum volume is only in case of 4 degree, but on decreasing further, if we decrease the temperature further, then what will happen? This volume will start increasing and density will start decreasing. Due to the decrease in density and increase in volume, ice floats on water. Clear? The next property is the anomalous expansion of water, which depends on this phenomena. Okay, what is this anomalous nature? That is the unusual property. See, as other liquids also do, water also do the same thing. That is, on cooling, first it contracts. That means means its volume is decreased. So on cooling, initially the volume of water decreases, and then below 4 degrees Celsius it starts expanding. As I said earlier, that at 4 degrees Celsius its volume is minimum. So first it contracts its volume, and then on reaching 4 degrees Celsius, if we further decrease the temperature, then its volume starts increasing. That is, water starts expanding. Okay, and it continues to expand till it reaches the temperature 0 degrees Celsius, that is at the freezing point. Okay, so if we plot the graph of density versus temperature, suppose this is temperature and this one is density of water, then suppose this one is the this is the 0 degree temperature, 0 degree Celsius. Okay, so at 4 degrees Celsius, near 4 degrees Celsius, if we suppose this one is 5, this one is 10, this one is -5, this one is, okay, let it be let this one is -10. So this will be the 4 degrees Celsius, this part. So at this temperature the density will be maximum, like this. And if we further decrease the temperature, see the density is decreasing, and here it forms like this. So at 4 degrees Celsius the density is maximum. Here you can see this is the maximum density, and on further decreasing the temperature, the volume of water will start increasing, it will start expanding, and the density will become will gradually decrease. Okay, this is the reason, means depending on this anomalous expansion of water, this enables the marine life to exist in the colder regions. Okay, what happens there? See, when the temperature, atmospheric temperature is very low, suppose it is 0 degree or in negative, then what will happen? The surface water which is in contact with the atmosphere, it will start freezing, it will become ice. But the water which is under that ice layer, okay, there the temperature is gradually there, the temperature is increasing. Means if we further move down, suppose this is the layer of water, this is the surface water, and above this surface the temperature is in negative or 0 degrees Celsius, suppose. So this one is the ice layer, this is the ice layer, and here as we move gradually down the water body, what will happen? Here the temperature will be in this way, 1 degree, 2 degrees, 0 degree, 4 degree. At 4 degrees Celsius the density is maximum, so here there will be no ice formation. Clear? So under the ice layer there is the water only, so in that water zone aquatic lives can easily live there. Okay, so this is the reason that due to the anomalous expansion of water, marine life can exist in the colder regions underwater. Clear? The next physical property of water is the latent heat of fusion of ice. So what does this term mean? This is basically the energy, means heat energy required to convert the substance from solid state to its liquid state. Okay, so if we want to define this term, that is the latent heat of fusion of ice, we need to say that the amount of heat energy required by ice to get converted into water. Okay, it is called the latent heat of fusion, but we must mention two important points, that is the melting point and the constant temperature. So if we write the definition, so the definition is the amount of heat energy required by the ice to form water at its melting point without any change in temperature. This is the complete definition. Now what is the value? There is a specific value of latent heat of fusion of ice. Okay, what is that value? It is 336 joule per gram or 80 calorie per gram. Okay, so the same amount of heat energy is released when 1 gram of water gets solidified from to form 1 gram of ice at 0 degrees Celsius, because 0 degrees Celsius is the melting point of water, and also it solidifies at 0 degrees Celsius. Now, depending on this latent heat of fusion of ice, we can explain that why the lakes and rivers, they do not freeze suddenly, because in the rivers or lakes there is impurities, right? So due to the presence of the impurities, its specific latent heat of fusion or latent heat of solidification, it increases. So due to the high specific latent heat of solidification or latent heat of fusion, the lakes and rivers, they do not freeze suddenly. Clear? I have already explained the latent heat of vaporization of water, right? But I haven't mentioned the specific value. So the value of the specific value of latent heat of vaporization of water is 2268 joules per gram or 540 calorie per gram. Okay, here it is. Here is the value, that is this one and this one are the specific values of the latent heat of vaporization of water. Now, as in case of the latent heat of fusion of ice, I said that it explains why that lakes and rivers, they do not freeze suddenly, right? Now, depending on the latent heat of vaporization, we can explain that why the steam causes far more serious burns than water. Okay, means at 100 degrees Celsius water starts boiling, we know that. So when the vapor pressure is greater and the temperature is greater, that means the specific latent heat of vaporization is also greater. Okay, so in that condition, steam causes far more severe burns than water at 100 degrees Celsius. So the burns caused by steam is due to the high specific latent heat of vaporization. Clear? The last topic which I will discuss today is the specific heat capacity. Before starting the specific heat capacity of water, I will discuss what is this specific heat capacity. What does this mean? It is simply a physical property, right? And for any matter, the specific heat capacity, it is the amount of heat to be supplied to a given mass of a material. Whatever the material is, when the amount of heat is supplied to a given mass of material to produce a unit change in its temperature, this is called the specific heat capacity of that matter. Okay, to produce a unit change in temperature, whatever the heat is supplied to a given mass of the material is called the specific heat capacity of that substance. Now, in case of water, if we want to change the temperature through 1 degree Celsius, for 1 gram of water, it absorbs 4.2 joules. So, for the conversion of 1 degree Celsius temperature for the mass of 1 gram of water, the heat energy absorbed is 4.2 joules, or it is called 1 calorie. Okay, so this value is the specific heat capacity of water. This is a fixed value, constant value, that for 1 gram of water, for 1 degree increase in temperature or rise in temperature, the energy absorbed is 4.2 joule, that is 1 calorie. Clear? This is called the specific heat capacity of water. So again, here another reason is there, that because of its high specific heat capacity of water, water is generally used as a coolant in motors or cars or desert coolers. Okay, so due to the high specific heat capacity of water, it is generally used as the coolant. Clear? Again, due to this high specific heat capacity, the land breeze and sea breeze, those phenomena are due to the high specific heat capacity of water only, because the presence of a large amount of water is able to modify the climate of the nearby land areas. So this makes the water warmer in the winter and cooler in the summer. So this is due to the high specific heat capacity of water. So I have explained all the physical properties of water today, and I won't explain anything else today. In the next class we will start with the nature of the solvent. Okay, water when it is used as the solvent, how is the nature, how it is used. I'll discuss it in detail in the next class.